Okay, so today's assignment is 3.2. It's about substitution and elimination to solve linear systems. Here on number 6, we have a linear system, and the key to identifying which method is preferable to use. Now, you can use either one anytime you want, but as far as preference, anytime there's a variable with a single coefficient. So right here I have 1x. That tells me that I'm going to key in on the idea of substitution. Now, I could still do elimination here. And you'll see how elimination works on the next problem. But here it is possible to do substitution, so I'm going to go ahead and do that. I need to first isolate this x. So I know that x equals 1 minus 4y, because to move the 4y I'd have to subtract. I'll put parentheses around that. Now this piece of information is equal to x, and x is right here in this equation. So I am going to substitute this information for x in the second equation. So 3, instead of writing x, I'm going to write 1 minus 4y, because it's equal to x, plus the rest of the equation, 2y equals negative 12. So there's the substitution piece. Now all I have to do is distribute and simplify. This is 3 minus 12y plus 2y equals negative 12. I'm going to subtract 3, and I'll combine these two in the middle. This should come out to negative 10y equals negative 15. Dividing by negative 10, I get that y is equal to 3 over 2 if you reduce by dividing by 5. So there's my y value. Now I need to know my x value, so I'm going to take this right back up here and substitute again. X equals 1 minus 4 times 3 over 2. Well, 4 times 3 halves is actually 6, so I get 1 minus 6, and 1 minus 6 is negative 5. So my answer is negative 5, comma, 3 halves, and that is, of course, an ordered pair solution. And so that is what substitution is all about. It's about replacing information and substituting into different equations for different information. Elimination is a little bit different approach. The idea behind elimination is that we want to physically cancel out either the x term or the y term. Looking here, 10 and 5 could both be multiplied to get to 10. Now that would be a number that both of them go into. 2 and 3 both go into 6. I don't care which one I do, but I need both equations to have one of those two for my x's or for my y's. Using 10 means I don't have to touch the top equation. So let's multiply our second equation by something that would produce a 10. And it looks like that'd be a 2. But also, be in mind that we want to have opposite signs so that when we combine, 10 minus 10 would cancel. So let's make this times negative 2. Alright, so equation 1 is still 10x minus 2y equals 16. But now this equation is negative 10x minus 6y equals 24. And so now as I work through this problem, these cancel, and I'm left with negative 8y equals 40. I divide by negative 8, and you get that y equals negative 5. And so here I have that the y value is negative 5. To find the x coordinate, I'm just going to plug this information in for y in either one of these equations. It won't matter. I'll take the bottom one. 5x plus 3 times negative 5 equals negative 12. And I'm going to distribute and simplify. So 5x minus 15 equals negative 12. Then I'll add 15 to get 5x equals 3. And I'll divide by 5 to get that x equals 3/5. So my ordered pair solution is 3/5, negative 5. Alright, and that is it. The whole kit and caboodle. Try to apply both of these where you think it's appropriate. Remember, when x or y does not have a coefficient of 1, substitution will be difficult because it will involve fractions. So elimination works best then, and just try to figure out which one you like best and try to stick to being proficient at least one of these. All right, good luck.